Thank you, Jean-Pierre. Bonjour à tous, moi je m'appelle Benny Diagre, je viens de Belgique, donc je peux parler le français un peu et je comprends le français aussi, mais je vais présenter en anglais parce que c'est plus facile pour moi de faire la présentation en anglais fluent. Mais si vous avez des questions, Jean-Pierre l'a déjà dit, vous pouvez les poser dans le chat et je peux répondre à les questions. So, welcome everyone else who doesn't understand the words of French that I just spoke. My name is Benny Diagre, and I am here today to present about designing impactful visualizations for your data, which means that we're looking at data visualizations and some common things on how we can do that. How are we going to do that? Well, I've got some things to show you, most importantly, but you also have to think for yourself, which is the most important thing. That said, I do want to express my heartfelt thank you to all of these sponsors for sponsoring this event, because I know for a fact that it's really hard to put on events without the helps of partners. That said, who am I? Well, my name is Benny de Jager. I am a senior data insights consultant at Inetum Real-Dolman. Real-Dolman is the Belgian enterprise in the global Inetum group. In any spare time that I have, I co-run this user group called datamines.be, which is the Belgian SQL Server user group that evolved into all things that is data and AI on the Microsoft stack. Senior data insights consultant, which means that I use a lot of fancy words to help customers get insights out of their data and take actions on that data. And data visualization is one of the very important things that are in my toolkit. If you want to reach out to me, my social handles are on there. At the end of the presentation, I'll also put in my email address. So if you have any questions after the presentation, feel free to reach out. That said, let's get kicking. I've done the raw version of this presentation as well at one of the universities in Belgium last year in March, and I asked them when we have to go in first. Is what are we doing right now? Well, I first want to give you some examples of what not to do, because it's very easy to make mistakes, but it takes the next level of not thinking things through to do some of the things that we're about to see. But how are we going to think? How are we perceiving these visualizations? There's a lot of psychology behind that as well. And that's something that we're going to dive into too. And it is key to pick the right visualization and the right colors for what we're trying to display, which is one of the ground principles of when we're working with data visualization. But as well is, how can we make this inclusive? How can we make sure that everyone understands what we're trying to convey as a message? So I have some sample things, some sample graphs and some sample visualizations, and they are all based on this data set. To give you some context, I come from the city of Antwerp. I live near there, and we have this thing called Velo. And for once, I don't have to explain what a Velo is, because you will all understand. But it is the system of shared bikes where you pick up a bike from the station, you drive around with it, and you put it back. I asked the city of Antwerp for the data. They wouldn't give it to me. I only could get aggregates, and I didn't want that. So I went looking on my favorite search engine, which is Bing or Ask Jeeves, and then I came to the city of New York, because they have the same thing. It is only tremendously bigger, because they have a lot more of these bikes, and they have a lot more traffic being generated on these. So the data is all publicly available. You can download it from their Amazon bucket, and you can use that to make your own sample data set to test out things for visualization. I also do it for performance tuning stuff. I also do it for query folding stuff. So it's a really useful data set that helps me do these things. But as I mentioned, I presented this session, the raw draft, at the university in Mechelen. And I asked them, and I am asking you the same thing as well, is when I say data visualization, what comes to mind? What is what you're thinking of? And I want you to think for yourself about the question. Feel free to put anything in the chat. Any input is more than welcome. But these are some of the things that the students came back with to me. And they were saying that it's graphs and it's charts, which is absolutely true. And it's used to portray a story. And then some daredevil put in pie charts. That's what his thing is that he's thinking of. And there's a lot of different things that they were saying that kept coming back, as well as something that they should think about more often. It's used to do maps. It looks easy, but it is very hard. And as well as that, well, you can just slap some things on there and be done with it. So very differing opinions, very different opinions. And in a way, they're all true to some extent, except the pie charts. That's not true. But that is something, if we look at things, the one answer that I want to get from them is that it's actually all around us. Because if we look around us in the daily life, maybe now not so much because we're all stuck at home, if you look around, you see data being visualized all around. For instance, this is one of the visualizations that is very commonly known and that is used a lot of the times. This is one to portray where you have these bottles of soda, Coca-Cola for instance, and how many cubes of sugar is in there. It's the equivalent of cubes of sugar that are in there. So most of us realize that when you're looking at this, we're consuming a lot of sugar and that we should be careful with the amount of Coca-Cola or sodas or whatever else we're drinking, that it might not be good for us if we're consuming large quantities. Well, if I put this visual in a different perspective, let's say, for instance, is if we're looking at the same bottle, and I'm looking here, and it's about 25 sugar cubes, and I'm looking here, and it's 6 donuts. Do you think the same? What's your instinct about how much sugar or how relatively healthy or unhealthy it is for you? No, because we're not used to having donuts as a measure of consumption. And then you get these people that proclaim that their only takeaway from this is that donuts are healthier than you thought, and that, well, people want to eat donuts right now. So it is by switching out the way of they're measuring things, we're telling a completely different story. But to get into things nice and easy, I want you to realize a few things. I'm dragging in a few inspirational quotes, but it is the fact that you need to realize that there is no such thing as a perfect dashboard. There is no such thing as a perfect graph. Data visualization and design in general is perceived subjectively. So people have different standards, have different desires, and they will respond to things differently. So what may be perfect for you may not be perfect for someone else. So there is no such thing, but that doesn't mean that we shouldn't try to aim for that perfect dashboard. So we need to think about what we're doing, and we need to think things through, making sure that the intelligence we put into designing these visualizations, that they come across to our end users. And then as well is that data visualization is what we're using as a tool to convey the message and to make sure that people understand what we're trying to express. Why does data visualization matter? Well, data visualization helps us change the way that we work with data. And it allows us to interpret large volumes of data in a clear and cohesive way. It allows us to make sure that users can look at large amounts of data and with a single glance of an eye, get a reaction, that they can get a feeling of how they're doing with this data. And it helps us recognize patterns and identify goals. So if we're looking at these same larger amounts of data, rather than looking at this gigantic Excel table, if they're seeing a graph, they'll have a much better time of seeing patterns in there, of identifying trends and issues that potentially may arise. But most importantly as well is that it can help us tell a story. It's the message we want to convey to our end users that matters here as well. So with the single click of a button, I added some color and I added some underlining there, and this completely changes the way that you perceive this message. So it is as well is that when we're using these things of color, our perception changes. But if we're looking at data visualization, well, we can look at it as it's both an art and a science. There is a lot of things that we need to think about when doing data visualization, but it is as much an art form where it is the matter of fact that how creative you are and how much of a flair you have to make these beautiful, stunning, and informative visualizations. But for the science part, we need to think for a bit about how our brain works. How does our brain interpret things? Well, roughly said, this is not a masterclass on psychology in the way the brain works, but roughly said, we have two different systems, a fast system and a slow system. And it's the fast system that we're using throughout the day, which makes these everyday decisions, which makes these intuitive and unconscious decisions on lots of things that we're doing. If I, for instance, were to throw a tennis ball at you and you have the reflection of putting up your hand to protect your face, that's these reflexes, that's these instinctive things coming into play. Or if you walk past the bakery in the morning and you smell the smell of freshly baked croissants and baguettes, that you have a craving for those, for instance. It's those things that are working in our fast system that happen throughout the entire day, effortlessly. And it's by having these influxes of it's by having these actions throughout the day repeatedly that it makes it easier and repetitively, and that it takes less and less effort to do this. But on the other side, we also have this slower moving system. The slower moving system that we use to think about things, that we use for analytical purposes, that we have to use for concentration and these harder things. So when we look at stuff being visualized on a plane, what do you think is being used primarily? It is mainly, spoiler alert, the fast system. When we look at a data visualization, first, it's the fast system coming into play and making some sort of decisions on them that will influence the way that our slower system is also working. So it's really important to try and guide these fast decisions to what we want them to have. So for instance, I'm going to the next slide. You need to very carefully pay attention right now because this is important. When you look at that slide, you need to see what the first thing is that springs to mind. Ready? 3, 2, 1. So for most of the people, if not all of the people, you're thinking about pink fluffy unicorns dancing on rainbows. And if the song is now stuck in your head, well, sorry, that's what you have to deal with for a Friday afternoon. Our mind is instinctively being drawn to the colorful image that we have, and the fact that I cheated by making it into a moving image is just, well, it's just me cheating to make sure that you're all drawn to the left-hand side. But on the right-hand side is, well, it is a mathematical equation. And if I were to ask you, if I had asked you in the beginning, please give me the result of the equation, while before looking at the pink fluffy unicorns dancing on rainbows, well, none of you would have been able to give me the answer. So to get this question out of your head, the answer is 322. And I've also put in the link to pink fluffy unicorns dancing on rainbows below, so you can go ahead and look at it. And that's correct. That's what Jean-Pierre is saying. It's the difference as well between endorphin and dopamine, the way that our mind works in these different things. So it is important to think at how these things work. Do we always need to keep this in mind? No, you can design visualizations without keeping this in mind, but you will have better success if you start working this into your principles gradually, if you start taking these things into account. But as well is our mind, for about 70%, give or take, it's not the complete actual math, works mostly for processing visual images, about 70%. Most of the iconic memory that we have and the short-term memory are used to process these visual stimulations. So data visualizations fall straight into the category of these cognitive things that we need to process. But enough theory, let me dive into a few examples that I've seen out in the wild. Not necessarily always as good as you might think. So if we go to the next slide, is there something that you see on this graph that seems a bit less than ideal? It's Spanish. My Spanish is not very good, but it is, from what I could gather, is that it's the amount of immigrants coming up to the shores of Spain based on the year that they have them. But what is a bit less than ideal here is the fact that the sizes of this graph are a bit skewed, because, for instance, if we have 4,500, that bar is bigger than the one in the year after, where it's 5,300 and a bit, and that the relative size of 57,000 is not nearly as big as it should be for this. So if we're looking at this graph, instinctively, we'd actually think that the growth is not as bad as we ought to think of it, that it's actually pretty much under control. So this is them using the wrong types of visualization to not convey the message. Or for instance, this one. This is one that I found on LinkedIn a few days ago. But as well as here, the thing is that they're using my my most favorite kind of data visualization of all times. But there is something a bit off about the pie chart, and especially on the text that is displayed above it, because they're claiming that 1/3 of their operating budget goes to financial aid. But like any other people, I'm making the sum of those two parts. I'm making the sum of the yellow and the red part, which is 80 million. And let's assume that 20 million is the budget that they're using for financial aid. That's 1/4 and not 1/3. But I also posted this in a LinkedIn group called Data Professionals Against Pie Charts. And there someone said that it's actually a relative pie chart, meaning that 20% is the relative size of the 60 million, which makes it somehow even worse. But as you can see, there's a lot of different things out there in the wild that are less than ideal. Not spending too much time on this one, but this is, for instance, a chart that makes... Yeah, Nikki, you're spoiling things. This is a chart that I use, for instance, when... well, this is an example that I use, for instance, for what does it actually mean? Because they're portraying, let's say, pies on a scale of 0 to 10. I'm assuming that it's rank on a scale of the amounts of vehicles registered, but opposed to what? What's the relative size of the balls? There's a lot of questions that I have in there. So it is not always that necessary. And this one, well, this is just bad. I'm not sure what to call this, but it's a 3D pie Bart gram or something. I'm not even sure what it is. And you're not supposed to be reading what it is, because it should hurt your eyes by now by being exposed to this for such a long time. But there are some exceptions to be made, obviously. For instance, if you've ever seen the show How I Met Your Mother, we all know Marshall Erickson, and Marshall Erickson has a pretty clear opinion on what his favorite bars are and what his favorite pies are. And he's portrayed them as well in what he thinks is the best visualization for that. But as well, this is one of my most favorite pie chart jokes as well, where we're using a pie chart to convey a message, and bonus points for whoever gets to say what I'm actually portraying here. This is harder doing virtual, by the way, but it is the lyrics of Hotel California by the Eagles portrayed on a pie chart, just to have some random pie chart jokes in there, because I do love me some decent pie chart jokes. But it's not all that. It is as well the fact that we've seen historically some very good examples. For instance, the Charles Minard map of the Napoleon's march on Moscow in 1812 is one of the most commonly used examples, where he's using 6 different dimensions to plot it onto a single map. And it takes you some time of looking at this, but it does portray a very good message for what's happening here. But the one thing that's not as commonly known is the candlestick chart. The origin of this candlestick chart is in the 1700s, somewhere in Japan, where it's been used for the Japanese rice exchange, where Japanese rice farmers could see, based on this chart, what the stock price of rice at that point was. And right these days, it's commonly used in foreign exchange trading, in cryptocurrency trading, and in stock trading as well. And it is the candlestick charts that easily, if you're used to reading these types of visualization, to reading what the trend has been on the different on the stock price in the past periods. So if it's green, it's an increase in the price. If it's red, it's a decrease in the price. And then it shows you what the mins and the maxes have been and where it started, where it ended. So if you're used to these things, it is a very powerful visualization. And the fact that this was invented somewhere in the 1700s makes it even more interesting that they were thinking about this at that time. But it boils down to how we're perceiving things visually and what we're doing with these things. So if you're looking at this image, what most of us are seeing is a black triangle overlaid on white dots, pie charts, if you will. But In essence, it is actually a black square with three Pac-Man figures laid on top of it. But it's our mind playing tricks on us by seeing things that are not there. It's our mind making interpretations that, well, it's been intended here, but in other cases, it's our mind playing tricks that should not be playing tricks. For instance, if I look at this, and most of the people would say that this is a Dalmatian. I've heard people say that it's a spotted horse kicking its hind legs or some other different things. So looking at this picture, there's a lot of room for interpretation. But if I make this into a moving image, that's when it becomes a lot more clear for people that this is in fact a Dalmatian walking. But it means what in general is that people can recognize objects even when they're not fully completed, when parts of these are missing. And that's one of the key principles of this thing called gestalt principles. And the gestalt principles, they're based on an Austrian and German school of psychology around the 1910, 20s, the year, I'm forgetting about the year. But they thought about design principles. So they're not principles made for data visualization. They're principles made for design, product design, user interface design, these kinds of things. But they also apply, mostly, a lot of them, they also apply to data visualization. And it's the way that our mind perceives things and how we can guide our end users to perceive what we try to purvey, what we try to put in there as well. And if we think about these gestalt principles of visual perception, what we need to realize is if someone looks for the first time at what we've created, how are they perceiving it? What's their mind doing? What's their reaction? And it's by thinking about these things that you can truly do some next level things with your data visualizations. So the Gestalt principles of data visual perception, they are roughly made to help you determine which elements are most effective in a given situation. What do you need to use when? What's possible on doing what works, what doesn't work. And they give us the ability to influence visual perception. Influence for good, but also influence for bad, because there is an entirely different topic related to how you can deceive people by making faulty graphs. Otherwise told as an evening with Fox News. But it allows us as well to direct attention to specific points of focus and make sure that people take action on this or that they think about what they need to be doing. Are my results positive? Are my results negative? Do I need to change something? But it also allows us to think about data visualizations that are intuitive and most of all functional, because if they're not functional, we're not going to do that much with them. So Gestalt most commonly portrayed as the Gestalt principles are most commonly portrayed as a collection of gray dots, and those gray dots have something happening to them. So right now we just have gray dots in 8 columns and 6 rows. But if I change one thing on them, is that they're no longer dots, but they're dots and triangles. Our mind is going to think about this and is going to perceive that there are 2 different groups, that the triangles are grouped together and that the circles, the dots are grouped together. So by switching out and by playing around with the form, we can help the mind make these instinctive decisions sooner. But it's the same thing with color. If I use these same types of representation and I use different colors, our mind is going to think that the gray dots are the same and that the different colors are meant to be different groups and portray a different message. This is known as the principle of similarity. And if I go quickly into a Power BI report that I made for these, for instance, I have this bland table, a bland matrix table inside of Power BI. Well, it is not meant to be a powerful data visualization. This is just meant for me to help you understand something. So what I have here is I have the amount of trips that have been done on said bicycles and the amount of trips that have been done in the year to date for that. So it is a bit hard to perceive, but if I change one single thing, the colors, it is a lot more easy to try and understand these. Are these the most beautiful colors and the most useful colors? No, it's put there to make it obvious for you that it's changing a lot of things. So right now our mind instinctively knows that the red pinkish columns, that they're grouped together, and that the baby blue columns are also grouped together. So it's just helping the mind see things that we need them to see, is what these things are all about. So it's the similarity principle. But the same thing is if we look at these circles again, is they're all circles again, and we're grouped into one, but now they are taken apart. And we perceive the image on the left-hand side as one group because they're all grouped together. But we also perceive the ones that are on the right-hand side as two different groups because they are taken apart. And how this relates in data visualization is mostly if we're using, for instance, clustered column charts or clustered bar charts, the grouping of them is important because they are portrayed on the same axis. But it also comes down to what we're doing with slicers and titles, because our mind will look at them, our mind will try to perceive if there are titles within those things. Because, for instance, I have a simple line chart, and I took away all the titles and I just put it on top of the left corner. And let's say for now that the data that's in here doesn't work with the different visualizations, that they don't work for all these different things. So it's less instinctive for an end user to know what is what. So if I change around some things by making sure that there is a title on each of these visualizations, and that these filters correlate to are placed next to the visualization that they actually work with, it is a lot easier to try and understand these things. So where you place your different objects, where you place your graphs, where you place your titles, your slicers, your filters, is a very important thing as well, because they play a large part in how users perceive this. It is known as the principle of proximity, by the way. Looking back at the dots, we have one group. And if I start drawing rectangles on them, well, our mind is now seeing three groups rather than one group. This is just the fact that we drew a rectangle over it and they are enclosed, or it's the principle of common regions, where we're looking at these things, and since they are located in the same container or rectangle, whatever we want to call it, we're thinking that they are grouped together. So looking back, if we're going back to the Power BI file, is I have 4 different graphs, and you're instinctively watching this and you're thinking, why has he put 4 seemingly identical graphs on there that have completely different meanings? Well, like I said, it is not meant to be a beautiful report. It is meant to explain something to you. But by making one simple change, by drawing a rectangle around them, not saying that it is what you need to do always, but by drawing a rectangle on them, it is more clear for you that these two are grouped together because they're both working on the duration, and these two are grouped together because they are working on the total trips that have been taken on the same axes. So it is by making sure that we use grouping where possible and where it's relevant, we can help end users, we can help consumers of your reports to think about what they're seeing. And then we have this principle as well. So if we take the most left example, for instance, do you see a straight line or do you see 2 curving lines? And that is something that differs for a lot of people. But most people, they are seeing a black line that is laid on top of a red line, and not a straight line and a swerving line. This is the principle where we're seeing the colors being continued across a different pattern, and it's the principle of continuity. And how is this most clear inside of our reports as well? It's pretty much the same thing that we're seeing right now. If we have 6 or 7 lines on a line chart and they're all the same color and they're making weird patterns, it's possible that we lose focus of where we're looking at. So by using these colors to make sure that that users can distinctively see which is which, we can help them see the continual line in there. And then as well is we have these 5 dots, and there are arrows drawn upon over them to make sure that we can understand that they're supposed to be moving. Or if I make this into a small GIF, is that we're perceiving them now as 3 of them are going up and 3 of them are going down. And both of them, those means that there are 2 groups of 3 dots each. And it is a principle of common fate, where our mind thinks that because they are moving in the same direction, that they are grouped together. And this one, the last principle, no, the second to last principle, is the principle where we're looking at this thing, and it's a very, very important, a very commonly known as well, and it's the one that I started with as well, is that we're looking at this, and either you see two faces pointed together, or you see a chalice. Or in the one here, you see either the Apple logo or you see Steve Jobs' face in there. And it's the figure where our mind thinks, it's the figure and ground principle where our mind thinks that it's seeing something different because of the way the background is portrayed and the way that the image on the front is used. So what we typically see this in data visualization is when maps are used. But in this example, it is actually just a picture of a map and they're plotting the dots on there themselves. But because of the fact that we think that it's a single image, our mind perceives the fact that the dots are actually on the right location because of the background that's used there. If we're looking at this image, our mind is instinctively drawn to the red square in there. It is the focal point of what we're looking at. It is the focal point where our attention needs to be drawn. So if I go ahead and look at what this is just a visualization where I have a lot of data not necessarily used correctly. And I forgot to show this as well with the continuity one. But if we make sure that our data is ordered in a manner that our mind can more easily process it, for instance, in the way that the values are descending or increasing, our mind has a lot less difficulties of perceiving this. But we're now just seeing a bunch of green, grayish visualizations on there. But if I change this, if I make this into a more colored visualization, that's where the attention is drawn instantly. So if you have something that needs to pop out, a mild dash of color is effectively what you need because it instantly takes the attention of your end user to what they need to be doing. And then if we're looking at this is where our mind is seeing a full circle, even though it is interrupted a few times. And it's known as a principle of closure. That's the one I also started with the Dalmatian. And it is the fact that our mind finishes images that it thinks it is. So if I look at a Power BI visual, for instance, where my data for August and September is missing, our mind is trying to make the continuation of that line itself. And it might be doing the wrong conclusions. It might take the right conclusions. Who knows? It's our mind trying things. But it's the fact that the data is missing. Our mind does try to complete that line into one. And in a nutshell, this is a lot of information to process, but in a nutshell, these are the gestalt principles. And if you're thinking about data visualizations, I personally think that you should take these into account gradually, that you need to start thinking about these, especially the ones for continuity, similarity, and proximity. Making sure that you use colors, that you are consistent with these colors, and you make sure that the things on your dashboard, the graphs and the elements on your dashboard or report are portrayed the way they should be portrayed. But what we can do additionally is leverage these things called pre-attentive attributes. Pre-attentive attributes mean that there are 4 different types of attributes that we can help users to make the first decisions on the data that we're seeing. And they're based on color, form, the movement of something, and the way that they are positioned on your dashboard or report. So these are all different options that you can use to influence form. But the ones that are with the blue little star next to it, those can only be perceived in a limited fashion. So it is not to be used overly detailed every single time. But these different options, and especially the sizes, the shapes, and the widths, are processed within 200 milliseconds of the first time we're looking at this visualization. So it is effectively, before we're thinking about what we're seeing, our mind has made these interactions and interpretations already. But it goes further because we can also start working with colors, we can start working with blurring, we can position these things, and that's where it gets really cool. But it is a very heavy topic, but these are the most commonly known principles that you need to be aware of when designing your dashboard. For the interest of time, I'm going fast over this one, is we're seeing a report right here where a lot of these things are displayed and a lot of these things are portrayed on the dashboard. So instinctively, most of us have the attention drawn to the top left because that's the way we've been trained to do things. It's the way the Western alphabet functions, where it's drawing our attention to the top left corner because we are taught to read from left to right and we start at the top. So in other cultures that are using different alphabets, this may differ. But if you're designing something for a Belgian or a French-speaking person that is taught the Western alphabet, that's the way that they are going to interpret these things. And it is better to switch out the logo, the right-hand corner, maybe even the bottom right corner, where it's the most important information that goes onto the left subside, because that's where we start looking. So it is also about choosing the right visual. And choosing the right visual boils down to knowing your data. What's the data? What's the data portraying? What are we trying to visualize? How is the data distributed? What's the minimum? What's the maximum? What's the distribution of it? Is it mostly on the outer sides? Is it on the middle side? How is it proportionalized? Are there relationships in there? Is it something that we need to plot on a map? There are a lot of questions that you can ask yourself. And it is very hard to put that into a 45-minute time slot. So what I want you to look at after today, when we're done with the Power Platform French Summit, is look at these links. It's most definitely the Financial Times visual vocabulary, because they've created a decision matrix on what you need to use when. If you know what type of data that you have, for instance, if you're looking at data that changes over time, then it can instinctively guide you to what types of data that you can use, what types of visualization that you can use for that. And it is making these decisions that help people interpret your reports more easily. But I need to move on, sorry. It is also about choosing colors. And it boils down to color theory. Colors are a subjective thing, and not every person responds to the same way. People have preferences, but it's also the same thing of culture. Red in our Western culture is perceived as a negative thing, as a not so positive thing, whereas in other cultures it can have a totally different meaning. But it is also, there's people that have done a lot of research on colors and how you can use them to make sure that you can make these decisions well informed. For instance, if we focus on the HSL model, the hue, saturation, and luminance model, that can help us decide on what we need to do. So the hue is described as what's the actual color. Is it green, red, blue, yellow? These are the colors that we know. And then the saturation is how much the color differs from neutral gray, where the luminance is the amount of black that is added in there. So if we're looking at the color picker from an application, how we're moving through this triangle completely differs for our saturation and our luminance, and how we're moving on the circle around it completely differs for our base color, our hue. But there are a few steps that we can take to decide on what we need to do. So for instance, step one is knowing the data. What do we need to do with it? Do some exploration on it. Make sure that you know what you need to pick, and decide on the aspect of your data that you want to represent. Is it the invoiced revenue? Is it the margin? Is it what you need to do? And then if you have those aspects, make sure that you pick one base color for every aspect. It is possible to use scales to make sure that you can visualize increases or decreases on the same aspect, but stick to the same base colors, the same hues. And the scale of your data needs to be understood as well. Is it sequential data when it's going from low or high, or is it diverging data, which has a lot of min and max data at those sides, but there is an important pivot table in the middle to make sure that we can use these what our data is doing and how we need to portray it. But most importantly is look at obvious options. If we're looking, for instance, to visualize weather data, and we're looking at the air pressure, the meteo, then we're looking at blue and red and purple as colors that are instinctively used and that people know. If there are obvious options out there, we can use those to make sure that we can pick these for our colors. Are they occurring in nature? For instance, if we're not in nature, but for instance, if we're looking at the colors of, if you're looking at the distribution of M&Ms in a bag of M&Ms, then you're not going to use green to display the yellow M&Ms and then purple for the blue M&Ms. It makes more sense to use the colors that are used. But as much as I love to talk about colored M&Ms, is there a corporate style guide for the organization you're currently working for? Do they have a style guide? And is that style guide usable to make these data visualizations on there? Because it makes sense to use these colors. But in general, we need to try and pick colors that our users will understand, that make sense for them. And then we need to decide on the base number of hues, the base number of aspects, because our mind is only capable of processing a limited number of hues, a limited number of colors. If we're looking at the data, then our mind is starting to struggle if we're trying to portray 7 or more colors in there, because that's when it just shuts down and we're having a very hard time perceiving things. And if it's more than 12 even, our brain is starting to have difficulties trying to differentiate the different values in there. So it might not necessarily portray the message that you need to have in there. And most important, that's the one I clearly want to address, is be consistent. Try to use the same colors across your different report pages, across your different reports. Use the same consistent colors within your team that is making these reports, because it will help end users understand. It will help those pre-attentive attributes that we've been discussing as well. They are used to these kind of things. And then, well, what you usually want to do is, when you've picked your base colors, is that you go ahead and create a color palette of these colors, making sure that you use colors that are aligned to these things. And there's multiple ways of looking at these colors and multiple ways of making decisions. But I encourage you to look at online resources to help you make these decisions. For instance, if you pick your base color and go to colorbrewer.com, the links are all in the slide deck. It'll help you generate a theme that is one of these 4 ways of displaying color. For instance, if it's monochromatic, if it's simple shades, if it's analogous colors, where they are closely on the color wheel, they are closely related to each other, where they're complementary from the other sides and that they completely make sense, or if they are triadic colors, when they're equally spaced around the wheels for a qualitative palette. It is thinking about these things, thinking about making your palette and having tools like these go build your base palette, makes it a lot more easier for you. But gray is an excellent color. Not everything has to be flashing orange and flashing pink. Gray is an excellent color to use in your data visualizations, because you can use a simple splash of color to visualize what you need to look at. White and gray can be used to add contrast in there, to make sure that there's spacing in there. But what I've done in the past as well is make my reports in gray, black, and white before choosing my colors, to make sure that I have my layout and that I can go ahead with these things and make these informed decisions, because I will have a grasp of what my data is, what I need to display, and these kinds of things. Lastly, because I am running very short on time, is I want you to make sure that it's accessible. Think about color blindness. Think about people with visual disabilities, motorical disabilities, hearing disabilities. Make sure that everyone can consume your data. So for instance, what I typically do as well is I take a screenshot of a report that I'm using and then go to the color blindness link. And this will give me an overlay with the different types of colorblind disorders that are out there, and if they're fit for it or not. And then make yourself a theme file. But looking at it, some takeaways really quickly as well is make sure that it's not an overload. Make sure that there's sufficient white space in there and that you think about the gestalt principles and the pre-attentive attributes. Your colors are meant to tell a story. Use them, but don't overly use them. Make sure that it's accessible and that you tell a story. I've included a lot of reference in there, references that I use myself, references that you can read through as well, and the resources to the different tools that I usually use. So with that said, I'll drop my contact email in there. I'd like to thank you for your attention. And if there's any questions, I'll gladly take them now. I'm sorry for going overly fast, but I had a lot of things to say.